Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of vectors as forces. So as per the problem, which of the following sets of forces acting on an object could produce equilibrium? Now equilibrium means that the vector sum of all the forces is equal to 0 or the forces balance each other out. Now there are two ways in which a set of three forces can balance each other out. So one way is this setup. So let's assume in this triangle the smallest side length is represented by the magnitude of vector v1 and the middle or the medium sized side represents vector v2. So its length is equal to the magnitude of vector v2, and the longest side in this triangle is represented by vector v3. So its magnitude is equal to the length of this longest side. So in this setup, we can conclude that the magnitude of v1 plus magnitude of v2 is greater than the magnitude of v3. So this is one scenario in which three forces acting on an object can produce equilibrium. So this is case one. The other case looks like this. So the smallest vector is v1, the middle one is v2, and the longest one is v3. So in this case, the magnitude of vector v1 plus magnitude of vector v2 is equal to the magnitude of vector v3. Now in this problem, we are focusing on the magnitude because in the given sets, we are only given the magnitude of the forces, we are not given their directions. So from these two cases, we can conclude that a set of three forces is in equilibrium if the sum of the magnitude of the two smallest forces is greater than or equal to the magnitude of the third force. So that means the so if this inequality is satisfied by the magnitude of the forces, that means the three forces can produce equilibrium. And in this case, V1 and V2 represent the two smallest forces in the set. So let's start with part A. So in part A, the two smallest forces are 2 Newton and 3 Newton, and their sum is equal to 5, which is greater than the magnitude of the third force. That means the set A can produce equilibrium. And this corresponds to case 1. Now we can analyze part B. In part B, the smallest forces are 9 Newton and 40 Newton, and their sum is 49, which is greater than the magnitude of the third force. So that means this set can also produce equilibrium. And this set corresponds to case 1. Now we can analyze part C. So in part C, the first force is square root of 5, and if we evaluate square root of 5, I get 2.24. So the smallest two forces in this set are square root of 5 Newton and 6 Newton. But their sum, which is equal to 8.24, is less than the magnitude of the third force. So that means that this set does not produce equilibrium. Now we can analyze part D. In part D, the two smallest forces are 9 Newton and 10 Newton, and their sum is equal to 19, which is also the magnitude of the third force. So that means this set can produce equilibrium. And this corresponds to case 2. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.